Hello everybody, myself Jyoti and this is lecture 5 on variation of carrier concentration with temperature. Here you can see the graph temperature variation of N and P for an N-type semiconductor. So here you have on y-axis I have log N and log P. On x-axis I have 1 by T, and here you can see three distinct regions. See, intrinsic range, then exhaustion range, impurity range. So let us try to understand what these three regions are. So I have three regions: impurity range, exhaustion range, and intrinsic range. Let us learn about this one by one. So what is impurity range? When the temperature is very low, very near to absolute zero, then in that case what happens? The Fermi level is in between the donor level and the lower edge of the conduction band, and the donor ionization is about to start. So as the temperature is raised, the donor atoms get ionized, and donor atoms will go from donor level to the conduction level, and that is how conduction takes place. So there is a very small gap between the donor level and conduction level. So even if the temperature is raised a little bit, then still the electrons from the donor level, they can go from donor level to the conduction level. So the electron concentration in the conduction band steadily increases, and this range is called as the impurity range, because here the conduction which is taking place, it is because of the impurities which we have added, because impurities only donate the electrons, and those electrons are present in the donor level. Now what is exhaustion range? At about room temperature, all the donor atoms, when the temperature is room temperature is more, then in that case all the donor atoms, they are ionized, and so the concentration of the electrons in the conduction band remains constant over a certain temperature range till certain value of temperature, because whatever electrons are present in the donor level, all of them have, by the time the temperature reaches room temperature, all of them, they have gone to the conduction band. So this region is called as the exhaustion range, and in this range Fermi level crosses the donor level. Hence the conductivity must be essentially constant over this region, because the donor level electrons, they are getting exhausted here. What is intrinsic range? As the temperature is still further raised, in that case what will happen? When you increase the temperature more than the room temperature, most of the bonds which are present, they are broken and electrons are set free. So the thermal ionization of the atoms in the valence band starts, meaning is electron crosses the forbidden gap, thereby increasing the electron concentration in the conduction band considerably. Now here when we talk about the valence band, it is an inexhaustible source of electrons, unlike the donor level. Donor level mein how much impurity you have added, depending on the electrons will be there. But when you talk about valence band mein there are number of electrons which are present. More and more of the electrons from the valence band reach the conduction band and completely outnumber the donor electrons. So that is what intrinsic range is. So in intrinsic range, if you check, whatever conduction it is taking place, it is because of the covalent breaking of covalent bond. That happens in case of intrinsic semiconductor, and that is how the name is given as intrinsic range. So the material practically becomes intrinsic at this temperature. Intrinsic at this temperature meaning is it becomes pure. It acts as a pure semiconductor in this particular intrinsic range. The whole concentration follows the dotted curve. You can see here in the graph, this is how the whole concentration goes up. So in intrinsic region, you can see there is a straight line graph. Of course, holes, they follow this dotted curve. And when you have exhaustion range, in that case the conduction is taking place from valence band to conduction band. So that is how the slope will be Eg upon 2 kb, because Eg, we know that it is the difference between valence band and conduction band. So here in exhaustion range, whatever current conduction is there, it is because of the electrons going from valence band to the conduction band. When we talk about impurity range, in case of impurity range, whatever current is there, it is because the electrons are jumping from the donor levels to the conduction region. It is because of the impurity atom. So naturally here the slope will be ED minus EC, difference between the donor level and conduction level, upon 2 kb. So about the levels and all, valence band, conduction band, you can just refer to the earlier lecture. So what is the highest operating temperature? So in practical devices, it is very necessary to operate either in the impurity range or in the exhaustion range, because we don't want pure intrinsic nature. The reason we have already seen in the earlier lecture. So if you want to take full advantage of the properties introduced by the impurities, either your device should work in the impurity range or exhaustion range. So there is a certain temperature up to which the material will act as a, it will operate in exhaustion range or intrinsic range. If you will increase the temperature beyond that, then covalent bonds will be broken and the material is just going to behave as a pure semiconductor. So the temperature at which the intrinsic conductivity becomes dominant, or the pure nature of that semiconductor material that becomes dominant, that means most of the conduction, it is because of the breaking of the covalent bonds, you can say, that determines the highest possible operating temperature. So if you take the example of germanium with the band gap 0.7 electron volt, it is around 100 degrees Celsius, and for silicon with a band gap 1.1 electron volt, the highest operating temperature, it is of the order of 200 degrees Celsius. So that is all about the three different regions. Yeah, thank you so much.